This is Algebra 2, Lesson 8-7, Factoring Quadratic Form. Our objective today is to apply basically all of your previous factoring tools for problems that have higher powers. And the main tools that we're going to be focusing on today is a sum and difference of cubes, a difference of squares, and ninja stars. We are not really doing factoring by grouping or advanced ninja stars in this lesson. All right, so higher power factoring. Something interesting happens when I change this. It used to be an x, and now I'm going to change it to x to the power of 2. If both of these are the same power, check this out. When you multiply these through, x squared times x squared turns into x to the power of 4. And then if I do x squared times this negative 5, I'm going to get a negative 5x squared. I'm going to do 3 times x squared. That's going to give me a positive 3x squared. And then finally, 3 times negative 5 is a negative 15. The main thing that I'm trying to show you is these two middle terms will still be the exact same power, because these two terms were the exact same power and these two terms were the exact same power, meaning I have like terms in here, and I can combine this to make this final answer x to the power 4 minus 2x squared minus 15. What I'm trying to get at is if this middle power is half of this power, I can go backwards from here to here. I'm going to write that down because it's important. So when this power, if this power is half of, I was supposed to write this power, then we can factor. So again, I'll show you a different case, and I'll show you what to be careful of. Let's go ahead and multiply. X cubed times x cubed is x to the power of 6. Again, you add power plus power to get 6. I'm going to do x to the power of 3 times negative 27, negative 27 x to the power of 3. Keep multiplying through. 1 times x cubed is plus 1x cubed. And then if I do 1 and negative 27, I get negative 27. Combine like terms, I get x to the power of 6 minus 26x to the power of 3 minus 27. And again, this power is half of this power, therefore we can go backwards from here to here. So let me show you why that's a problem, because if I go from here to here and I keep going backwards, these can both be factored even further. Did you realize that this is a sum of cubes? Did you realize this is a difference of cubes? Both of these have giant ways of factoring even further, and these problems can get really gross really fast. Let's start off with a nice, easy example 1. All of these have 2 parts, so they can fill both halves of the page here. In example 1a, I want you to factor this nice, easy problem. I know that the answer is going to be factored because this power is half of this power. I can say, okay, it's clearly going to be m squared with something else, and then m squared with something else. That's the basic setup for all of these. It's always going to be that one here. That's the pattern that I saw up here. Whenever I have that middle number, it's the middle number that matched up here, right? Okay, so then you're doing your basic ninja star. What 2 numbers multiply to negative 48 and add to 2? 6 and 8 seem pretty good choices, and you would be correct. It's a plus 6 and a minus 8. And at this point, you always want to stop. Can you go further? That's the really big question today. How far can we go? This can't go any further. Is this a difference of squares? I have a minus sign. Whenever I have a square and a minus sign, you need to be suspicious of difference of squares. 8 is a cube, not a square. So that is our final answer. And I did tell you that this one would be nice and easy. I think from here on out, they get harder and harder and harder, though. All right, let's try the next one. All right, well, the first thing I'm noticing is that this term is not half of this term, so I'm just done. Haha, wait, there's more. You have to divide all of these by the greatest common factor. So the greatest common factor for each of these, I can factor out an x, but I can factor even more than that. I can factor out 2 for each of these. And when I factor out the greatest common factor of 2x, what's left over is an x to the power of 6 plus an 8x to the power of 3 plus a 12. And you'll notice this power is now half that power, which means we can use our ninja star. So let's leave the 2x factored out. We can say 2x is still right there. what's going to be on the inside here. First, what power am I going to have? It's going to be x to the power of this thing right here. And I want to change this color to, I'm feeling green, so we're going to say x to the power of 3 has to go here, x to the power of 3. This middle term power always matches with these. Okay, then you're doing your basic ninja star. What two terms multiply to 12 and also add to 8? I'm thinking 6 and 2 add to 8 and multiply to 12. So we're going to say plus 6 plus 2. And okay, the cube, when you have a cube, you need to be careful of both the plus signs and the minus sign. You can factor both a difference and a sum of cubes. If you have not memorized all of your perfect cubes all the way up through 10 cubed, you need to go practice that blue kit. 6 is not a perfect cube. 2 is not a perfect cube. So luckily we are done. I'm just warning you guys what you need to be thinking about when you're seeing these problems. What are the things like perfect cubes, those sum of cubes, difference of cubes, difference of squares, that stuff. This one I think should be bigger. I don't remember what I did on this one. Okay, first of all, I'm seeing a greatest common factor. Let's go ahead and do that first. Greatest common factor here, I can factor out a c. Can I factor out a 4? I can factor out a 4 because I can divide both of them by 2 twice. So if I do that, 4c is factored out. What's left over in here? I have a c to the power of 4, c to the power of 2, and no c. I have a minus 7 and a minus, what is that going to be? 18, it looks like. And then again, ninja star, what two terms multiply to 18 and add to 7? 2 and 9 would be pretty safe choices. So I'm going to say 4c. And then on the inside here, I'm going to have c, again, I'm going to do this power right here. So c squared and c squared. And I knew it's going to be plus 2 and minus 9. Okay, so I have squares. I don't have to worry about the pluses. There's no such thing as sum of squares. But there are differences of squares. And hey, 9 is a square, which means this one can go even further. This one can go down into a c. Okay, you do the square root of 9, right? Square root of 9 is 3. So it's going to be c plus 3 and c minus 3. And then I have to rewrite all this other stuff as well. 4c times c squared plus 2. And there's our final answer. Excellent. All right, let's move on to example, this is 2b, I think. Example 2b. All right, so from here, I'm going to factor out the greatest common factor, which is none of them. The fact that this is a harder question than the last one with no greatest common factor is making me a little bit nervous. If I can't factor the greatest common factor, I immediately go into my ninja style. This is going to be m, and I notice that this power is half of that power, so it's going to be m to the power of 3 with something, and m to the power of 3 with something. Okay, and what are the factors of 4? 2 and 2, which don't go to 5, so it must be 1 and 4. So plus 1 plus 4. And this is where you want to be checking. Anytime that you have a cube, you need to be checking for a sum of cubes or difference of cubes. 4 is not a cube, it's a square. 1 is always a cube, and it's always a square. This factors further. To remember how to factor a sum of cubes, you need to have these memorized. And I know that the way that we showed this work was you divided this one by m plus 1. I know that m plus 1 is going to be one of the factors. And that's what we showed in the notes last time. So this is going to be m plus 1, which is one of the factors. And this other thing in here is going to be m squared. And I know the very last term is going to be 1 squared, or just 1. And then I still have this m cubed plus 4. What goes on the inside here? I know I have to have a minus somewhere, so it's going to be minus. And then I multiply m and 1 to get 1m, which is just m. And then 1 squared is just positive 1, so plus 1, and I get my final answer. I highly recommend pulling back up your notes on 8-6 on factoring perfect cubes to make sure that you have all those ready to go. All right, example 3a and 3b, and then we're done. So example 3b, factor out the greatest common factor. This one does have a greatest common factor. I'm noticing y can be factored out of each of these, meaning having a y with what's left over here, a y to the power of 8 plus a 4y to the power of 4 minus a 32, which is interesting because this is 8 going down to a 4. Okay, so I know that I'm going to have the form which is y times It's going to be y to the power of 4 with something, and y to the power of 4 with something. It's annoying me that that doesn't look red. It should match the rest of them. Okay, so Ninja Star, what two things multiply to 32 and add 4? And I'm seeing 4 and 8, right? So we'll do plus 8 and minus 4. All right, this is one of those things where you might not have even thought about it, but this is a square. You might say, no, that's a power of 4. This is a square. Watch, because y squared is y to the power of 4. Therefore, this thing is a square. It's this thing squared. It's y squared, so it is a perfect square. This is a square, this is a square. It's a difference of squares. Anytime you have an even power right here, you need to worry about a difference of squares. So from here, we're going to say that this is y. We still have this y to the power of 4 plus 8. You can't have a sum of squares, so I don't have to worry about the plus sign. This thing is going to factor down into y to the power of 2 and y to the power of 2. Again, you're always going by half that power, that leading power, I guess. And then one of them is going to be plus 2. Ooh, this one's going to be plus 2, and this one's going to be a minus 2 for our final answer. All right, and then moving on to our final problem, which maybe is the hardest out of all of them. I don't know. It's up to you to decide. It's your opinion. We have to have a greatest common factor. This one looks like it has a greatest common factor of just w for each of these terms. So if w is factored out, what's left over is a w to the power of 6 minus 4w to the power of 3 minus 32. Okay, so from here, I'm going to Ninja Star this. This is going to be w times w to the power of 3 with something, and the w to the power of 3 with something. I'm noticing I'm not doing a very good job with my color coding. Let me change all this to a better color. It's going to be w to the power of, 6 minus 4w to the power of 3 minus 32. This is going to be w to the power of 3, w to the power of 3. Okay, 32 and 4, that's going to be, it's 8 and 4 again, isn't it? That's the same thing that we had last time. But it's slightly different now. It's going to be a negative 8. It's going to be a negative 8 and a positive 4. Okay, whenever there's a power of 3, you need to be on the lookout for both positives and negatives. Anything that are perfect cubes are fair game. That's a square. That's the cube. So we're going to go ahead and factor that one. So I'm going to rewrite this one and this one on the left and the right. So we have a w right there. We have a w cubed plus 4 there. And then you have to memorize, how do you do a difference of cubes? So a difference of cubes is going to be a small one and then a big one. Difference of cubes, we always start with that same sign on the first one. It's going to be w minus 2. I'm just thinking, did I do my difference of cubes up here correctly? I did, okay. And then down here, we're going to say that this is going to be w squared, and then this thing squared is going to be 4, positive 4. And then remember that this sign always switches, so it's going to be a plus sign over here, so it's going to be plus, and then I just multiply together 2, laser pointer, 2 times w, and it's going to be 2w. All right, cool. There's the final factorization of example 3b, and we are done. So just be on the lookout for all the perfect squares, all the difference of squares, all the difference of cubes, and all the sum of cubes, while also applying this new form of Ninja Star rule. I know it's a lot, and you guys got this though. All right, that concludes Algebra 2, Lesson 8-7, Factoring Quadratic Form. Thanks for watching.